Good morning. I'm now going to do the words for chapter 27, words 20 for the 23rd and 24th of April. We're starting then with the outer planets on page 701 of your book, and you can follow them along with the diagrams in your book, and I have one up on the board in a minute. The first one there is gaseous planet. What are gaseous planets? Well, from Greek, chaos, gas, gigantum, I can't even say the word, large, okay, large, giant. A planet that has a deep, massive atmosphere such as Jupiter, Saturn, Uranus, and Neptune. The next one is the Jovian planets, like that of Jove and planet Wanderers, and any one of the first four outer planets the same. Jupiter, Jupiter, Saturn, Saturn, Uranus, Uranus, Neptune, Neptune. There's another name for these outer planets. And look at your diagram. I think it's very good in your book. It's sort of a relation of size. Notice this one here. They have the first one that they thought had rings. That's why your book is sort of out of date, because we know that some of the other outer planets also have rings. But most people just think Saturn has rings. There's Jupiter down there, and we'll talk about Jupiter in a minute with its moons. And then you have Neptune and Uranus. What's missing, of course, is Pluto. Move it up, please. Compared to the Earth, you can see how big these gaseous planets are. Now, this is a model. It's a man-made representation. It's not very accurate, but it just gives you the kind of relationships. Jupiter, father of the god Zeus, the first outer planet and the fifth planet from the Sun, and the largest planet in the solar system. 11 times the diameter of Earth, and 1,000 Earths equal the volume of Jupiter. Its orbit period is almost 12 Earth years and rotates faster than any other planet once every 9 hours and 50 minutes. Wow! Jupiter has at least 16 moons, probably many more now that we can find with the satellites. And it has one giant red spot. It's a huge hurricane storm, as Dr. Wood told you once before. Now, it has 4 major moons, and these are very important. Why? They were discovered by Galileo with his telescope, proving, that's why they're called Galilean moons, proving that the sun was the center of our solar system. And he named these Io, Europa, Ganymede, and Callisto. So you should know those 4 moons. Okay? The next outer planet is Saturn, god of agriculture, from the Latin verb sero, serere, sebe, satum, to sow or plant. You can see how useful Latin is. The 6th planet from the Sun, and is over 500 million kilometers farther from the Sun than Jupiter. Wow, you just can't measure. You have no idea what these distances mean. Saturn is the 2nd largest planet with an average temperature of minus 176 Celsius. Saturn has at least 20 moons, probably up to 30 now, and rotates once every 10 hours and 30 minutes. Its orbit period is 29.5 Earth years. That's how long it takes it to go around the Sun, 29.5 Earth years. Saturn has a series of rings. Remember, we saw that in the first diagram. Uranus, okay, the personification of the heavens, the 7th planet from the Sun, and the 3rd largest planet in the solar system. Uranus is 3 billion kilometers from the Sun. 3 billion kilometers. And its orbit period is 84 years. It has at least 24 moons and 11 smaller rings. Now, these were discovered by our satellites, of course, that we put up. Uranus rotates every 17 hours. So all these gaseous planets move pretty fast and on their rotates on their axis. Sorry. Neptune, the god of the sea, Poseidon, the 8th planet from the sun, and is similar to Uranus in size and mass. Its orbit period is 165 Earth years. That's how long it takes it to make an orbit around the sun. And it rotates every 16 hours, very fast. Neptune has 8 moons, many more than that now, and possibly 4 rings that were discovered. Some of the rings are so fine, even the satellite images have a hard time differentiating them. It is 4.5 billion kilometers from the sun and has wind speeds approaching 1,000 kilometers. We had wind speeds here 50 miles an hour to 70 miles an hour last week, and you saw what damage that did. Can you imagine winds 1,000 kilometers per hour? It's just impossible. And finally, this is where the great debate comes. Is Pluto a planet or is it not a planet? Well, it's not like the other outer planets because it's not gaseous. The 9th planet from the sun has a diameter of 2,390 kilometers, making it the smallest planet in the solar system. Pluto has the orbit period of 250 Earth years and rotates once every S days. I don't know what S8 days it might be. I can't read the writing. Sorry, and I forgot it. Pluto's orbit is very elongated in ellipse and on different plane. That means all the other planets are on one, think of a plate, all going around in a circle around the sun. This is off a little bit, so sometimes it's not the furthest planet. Sometimes it is the furthest planet because it's on a different plane. They'll never collide. And the plane then that of the other 8 planets. Pluto has 1 moon, Charon, discovered by the Hubble telescope. Next, please. Now this is diagrammed directly from your book, and he talks about the last moon. That last thing, Sedna, is a Inuit, Eskimo word. Well, no, I want the picture, please. And it shows this. And here is another moon. Here is Pluto. Now these are so far, they're not classified as planets. Look at our moon compared to Pluto. Pluto is even smaller than our moon. Next, please. Word 44, the Kuiper Belt, a region of the solar system that is just beyond the orbit of Neptune and that contains small bodies, made mostly of ice. I'm doing all the words just to finish them so you can then do the other review questions on the next day. So we're getting the words done today. Word 45, we talked about Sedna, Inuit or Eskimo word, goddess of the ocean for them. An object about 3/4 the size of Pluto. It is 3 times further from Earth than Pluto and is not classified as a planet. Now you have a funny word, exoplanets. What does it have to do? Exoplanets means planets that orbit stars other than the Earth's sun. Any planet that orbits around our sun is not an exoplanet. And they keep finding many, if you read in the newspapers almost, they find other planets on other solar systems out there. Now here's Kepler's second law. I wish Dr. Wood was here. But it's because you speed up in your orbit around the sun, you go faster when you're closer to the sun, and as you get further away, you slow down, so that if you took this area or this area, they have to be equal. And that's what happens. They can go so fast, so the time is equal. Planets move distance x and distance y in the same amount of time. Woo-woo, woo-woo. Planets move fastest when nearest the sun. And that's Kepler's second law. We talked about that before. I think that's all the words on this. I love this one again. Remember, we're reviewing. The first person to extrude this, you had the Aristotelian model of the Earth in its center. and all the other planets and sun were going around us. But they couldn't explain the retrograde motion or why Venus is sometimes seems to appear to be a morning star and then an evening star, and how do you explain that retrograde motion? They did it. Who did this? Ptolemy. He added the epicycles. Epicycle, 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 to get this movement of small circles upon larger circles, explain retrograde motion. Then came our little friend Kepler. Not Kepler. I can't think of the one. Ooh, Kepler is the one that gave all these things and so forth. But then you had what we call the heliocentric model by Copernicus. Copernicus. He was the one that first postulated that we go around the sun. And that was proven in great detail by our friend Galileo. So I want to stop now today, and I want to thank you very much, and I hope everybody is well, and I hope these little lessons on the video do help you. If not, just ignore them and continue reading the book and doing the questions. Thank you very much.